Hi, I am Dr. Samir bin Osman, and today we're going to talk about the principles of geology. So, geology is the study of the structure and the composition, as well as the change in processes of rocky planets. And we're going to focus on Earth here, but basically the principles apply to any rocky planet that we know of. So, as the Earth formed, lighter elements floated and cooled while denser elements sunk to the bottom of the Earth. And that's how we ended up with the Earth with a rigid crust and a molten mantle and then an iron core, because iron is the densest of materials. And iron actually is important because it can, it makes a magnetic iron core. And that magnetic iron is present in sufficient quantities in the Earth's core to generate a significant magnetic field which extends far beyond Earth and actually protects our atmosphere from quote-unquote erosion or scraping by the solar wind, which is made of charged particles, and also shields us from harmful cosmic rays that are coming from the supernovae in neighboring systems. And also the heat of the molten core of the Earth comes from the weak force actually, and I'll send you to the principles of physics on the forces of the universe. But there's about 44 trillion watts of heat that's generated in the Earth by the decay of radioactive isotopes that have, just for a quick recap, radioactive isotopes have a higher number of neutrons in their nuclei than protons, and so they're unstable, and they will seek to get rid of those additional neutrons, and they will do so through the weak force, which will send beta radiation, which will kind of generate heat. And so that heat causes actually boiling, let's call it, in the inside of the Earth. And that boiling is going to produce convection currents. Just like you boil, water in a pot and you see kind of those convection currents going up. Well, kind of a similar thing is going inside the Earth at different time scales, of course. And so that boiling in the lower mantle is going to cause the crust that's floating above it to move. And that movement is going to cause what we call tectonics. And so tectonics is very important actually, and we're going to talk about it in the next one. So tectonics is basically due to the fact that different regions of the crust and upper mantle of the Earth have different compositions, and therefore will move differently, and they will form plates, and those plates are called tectonic plates. So tectonic plates will move as a result of the convection of the currents, and they're essential for life actually, because first they act as a global thermostat. Because they cause the creation of volcanoes, and the volcanoes will release CO2 into the atmosphere. And as we'll see in the lessons about climatology, in the videos about climatology and geography, CO2 is a greenhouse gas, which means that it retains the sun's heat. And so it makes the Earth warm, but we don't need to make the Earth excessively warm. And so tectonics also actually constantly buries excess CO2 in the deep layers that go inside the oceans. And so it maintains basically a healthy amount of CO2 in the atmosphere. Tectonics also brings life essential minerals to the oceans and the frost and the floor of the Earth. And so basically it fertilizes the plants on the Earth as well as in the oceans. So adjacent tectonic plates, they will move relative to each other, and they will form one of three types of what we call boundaries, which can, by the way, all cause earthquakes. So we have the first type, which is convergent boundaries, i.e. they move towards each other, and they will form mountains on one side, subduction zones on the other, as well as volcanic islands. Then we have divergent boundaries, which move away from each other, and they form mid-ocean ridges. And then we have transform boundaries, i.e. they grind against each other and they form faults, like the San Andreas Fault in California. So these tectonic plates, when they cool down, they will cause the formation of rocks. So what are the principles that govern the formation of rocks? So rocks are formed and transformed because of plate tectonics again, as well as weather. So the divergent boundaries, they will bring hot magma to the surface. And then upon cooling, it will form fiery or igneous rocks. And here we have some examples of igneous rocks, such as granite and basalt and obsidian. Igneous rocks are the oldest type of rocks on Earth, and they are very hard and resistant to extreme heat because that's how they were formed. And they're also devoid of fossils as they are formed at a relatively fast rate, i.e. thousands of years, as opposed to millions of years for the rest of the rocks. And so they don't have enough time to entrap plants and animal remnants. Now, deposits of pre-existing rocks or dead organisms that accumulate on the Earth's surface and get buried over time, get buried more and more, and then they get under more and more pressure, and they're compacted and cemented until they form what we call sedimentary rocks. Sedimentary means like they deposit. And some of the examples include limestone or sandstone or coal. Coal actually, yeah, it's a sedimentary rock. So sedimentary rocks are less hard than igneous rocks and are formed over long periods of time, millions of years, as opposed to the igneous rocks that are formed over thousands of years, which explains the presence of fossils within them, as well as the presence of coal, like we said, which is made from plant and animal remains and is used for fossil fuels, as a fossil fuel. Now, when magma comes into contact with other rocks and under extreme pressure or temperature, that is hot enough to reorganize matter within the rocks, but not hot enough to melt them, they will metamorphose into what we call metamorphic rocks, such as marble or quartz or slate. And those metamorphic rocks are almost always harder than sedimentary rocks and are also formed over long periods of time, i.e. millions of years. But since they're formed under like the tremendous heat and pressure, they do not harbor fossils. So you can only find fossils within sedimentary rocks. Now, these rocks will be deposited into layers with the addition of new, i.e. younger layers over time on top of each other. This helps date geological features because the more recent ones are the superficial ones and the deeper ones are older ones. And so the geological features, we can trace their formation history throughout this feature. We can also date the geological features using the remaining proportion of the radioisotopes that we spoke about. And so by measuring the proportion of, let's say, the radioactive carbon, which is carbon-14, as compared to the non-radioactive carbon, and as we know that they decay at predictable rates, we can calculate how long it has been decaying for and how old then this feature is. So carbon-14 is used, but it's not the only one. We also use potassium-40 as well as argon-40 for datation purposes. Now these rocks and layers, how do they behave over time, and what are the processes that shape their behavior? So there are three main processes that shape geological features: uplift and deformation, erosion, and weathering. And it's important to note that they occur simultaneously. It's just that we're separating them here, again, for like learning reasons, just because our brains are limited, but just bear in mind that all they occur simultaneously at various levels. So let's speak about the first one. So uplift and deformation is caused by plate tectonics at convergent and transform boundaries. And they cause layers to be basically pushed up, i.e. uplifted, or folded, i.e. deformed, or cracked, thereby bringing deeply buried layers to the surface and forming mountains, plateaus, and faults. As you can see in this image, you can see the uplift and the deformation that occurs over thousands and millions of years. In addition, we have another process, which is erosion, which is the continuous action of wind, water, and ice on rock layers over millions of years, which erodes them, forming a wide array of geological features that can range from canyons, valleys, riverbeds, lakes, caves, arches, dunes, fjord, and many, many more. As well as producing, this erosion is going to be producing mineral-rich sediments that are carried by waterways to land and to the oceans, where they will fertilize plants and algae, respectively. In addition to that, we have weathering. And so what's weathering? So rocks also will react physically with the wind and the sand and the rain and freezing and thawing, as well as chemically with the oxygen in the atmosphere, water chemicals that are found in the water, like, such as acids, as well as biologically with plant roots, as well as microbes, etc. So all these physical, chemical, and biological effects are called weathering, and they will cause rocks to break down over time and then form soil, actually fertilize, like fertile soil, but they can also form sinkholes, they can form caves, and also like give like a rusty or oxidized geological features like the one you see here. And the bright red-orange color is caused actually by the action of oxygen on the iron that's present in the rocks. And so that's kind of a quick overview of the principles of geology. We are at the end of our video. I would appreciate your comments. I'll see you in the next video, and thank you for your attention.